Good day everyone, my name is Aoyong Huixia. Today, I will be presenting design and analysis of ECG signal conditioning system using a BJT as an amplifier and MOSFET as a switching device. An electrocardiogram ECG signal conditioning system is a biomedical technique used to measure the electrical activity of the heart. The electrocardiogram represents an electrical tracing of the heart and is recorded non-invasively from the surface of the body. By examining changes from normal on the ECG, the doctor can identify a multitude of cardiac disease processes. However, the electrical signal generated by the heart are extremely small, usually in the millivolt range, which is 0.1 to 5 millivolt. Because of this very low amplitude, the signal cannot be directly processed or displayed due to heavy background noise. They must first undergo signal conditioning, including amplification and signal control. In this system, BJT is used for signal amplification, while a MOSFET is used as a switching device to control the signal flow. Without this component, the ECG signal would be too small and noisy for practical use in medical system. Before discussing the circuit, we need to know some characteristics of the nature of the ECG signal that are related to the topic discussed today. First, ECG signals are incredibly weak with a very low amplitude, typically ranging from 0.1 millivolt to 5 millivolt on the body surface, with a standard amplitude of about 1 millivolt. In addition, ECG signals are highly vulnerable to noise and artifacts. Due to their low magnitude, the accuracy of the ECG is easily affected by external and internal interference. One common type of noise is the baseline wonder, which is a slow variation of the signal, usually below 0.5 Hz. This is mainly caused by respiration and slight movement of the body, which changes the electrode contact resistance on the skin. Another important source of noise is power line interference at 50 or 60 Hz, which comes from surrounding electrical equipment and electromagnetic fields. Because of ECG are so weak and easily affected, they require amplification using low noise transistor like BJT to improve signal quality before further analysis. Now, let's move on to system block diagram. This simplified block diagram shows the signal processing stages in ECG monitoring system. First, ECG electrode detect the electrical activity of the heart from the body surface. Since the ECG signal is very weak, it is first amplified by a BJT preamplifier, followed by a BJT main amplifier. After the amplification, the signal is then passed through several filter stages to remove unwanted noise, including the power line interference and high-frequency noise. Finally, the processed ECG signal is displayed on a monitoring system for visualization and further analysis. In this presentation, I will mainly focus on the BJT amplifier stage, which are responsible for increasing the amplitude of the weak ECG signal while maintaining the signal integrity. This stage is the main amplification stage of the ECG system, and it uses a common emitter BJT configuration. The weak ECG signal is applied to the base of the transistor. A small change in the base current controls a much larger current flowing from collector to emitter. As a result, the signal is amplified and the output is taken from the collector terminal. The main purpose of this stage is to increase the amplitude of the ECG signal while maintaining its waveform shape. This is very important because the ECG waveform contains clinically significant features such as the P wave, QRS complex, and T wave. BJT is used here because it provides high gain and is suitable for low-frequency analog biomedical signals such as ECG. In this configuration, the BJT acts as a current control current device, which allows small input signals to produce larger output variation. Now, let's move on to MOSFET switching stage. In this system, the MOSFET is used as a switching device. Its main function is to control whether the amplified ECG signal is allowed to pass to the output stage. When the MOSFET is turned on, the signal is transmitted to the next stage. When it is off, the signal path is blocked. This switching function is very useful in biomedical system where signal routing or control operation is required. So, MOSFET is suitable for this role because it has high output impedance, low power consumption, and fast switching characteristic, making it efficient for controlling signal flow without affecting the previous amplification stage. So by comparing to other transistor, MOSFET is preferred because it consumes less power and provide efficient switching. This slide shows how the ECG signal changes as it passes through the system. The input signal from the heart is very weak in the millivolt range. After passing through the BJT amplifier stage, the signal amplitude increases significantly, making it easier to observe and process. Then, the MOSFET switching stage controls whether the signal is passed to the output system. Importantly, the waveform shape of the ECG signal is preserved throughout the process. Only the amplitude and signal flow are modified. This is important because ECG waveform contain clinical information such as the P wave, QRS complex, and T wave, which are essential for diagnosis. After knowing the application of BJT and MOSFET in ECG signal conditioning system, let's move on to biomedical application context of these two systems. Application of the system include hospital ECG monitors, portable ECG devices, wearable health monitoring system, and remote patient monitoring system. BJT-based amplification circuits are widely used in biomedical electronics because biological signals are typically very weak and require proper conditioning. Without proper amplification, accurate monitoring of heart activity would not be possible. In modern healthcare, there is an increasing trend toward wearable and continuous monitoring system, where patients can track heart activity in real time outside clinical environments. This makes efficient and low power circuit design very important. As a conclusion, ECG signals are very weak biological signals that require signal conditioning before they can be processed. The BJT amplifiers plays a key role in increasing the signal amplitude while preserving waveform characteristic. At the same time, MOSFET also provides an efficient switching mechanism to control signal flow in the system. Together, these components form a basic but effective ECG signal conditioning system used in biomedical electronics and patient monitoring application. Because of this reliability and efficiency, this type of circuit is widely used in modern biomedical instrumentation. That's all of my presentation. Thank you for listening and attention.